We're talking about combinations and permutations today, and they are an important element of statistics and probability that freak a lot of people out just because they've got these big fancy names, but really they're not hard, okay? So first of all, let's figure out what they're all about. Why do we even have combinations and permutations? Well, basically they tell us how many different options we have when we're trying to combine certain things. So say we have 16 people running a race. A combination or a permutation could tell us how many different ways could we pick 3 people out of those 16. So maybe how many different ways can we pick first, second, and third? Now, they have a difference between permutations and combinations. They're not the same thing. And I'll tell you how I remember them is I remember that this lock down here, in English, we call this a combination lock because we use the word combination in all different ways in English. And we call this a combination lock, right? But in truth, this is not a combination lock. And the locks on your lockers are not combination locks. They are permutation locks. So what is the difference between a combination and a permutation? Well, basically, for one of them, order matters, and for one of them, order does not matter. Okay, and when I mean order matters, I say, okay, if I pick out numbers 1, 2, and 3, that is a different group than 3, 2, 1. That means order matters, right? Because it's the same 3 numbers, 1, 2, and 3. But if they're in a different order, in a permutation, that's a problem. Just like in this, what we'll call a permutation lock, right? In this permutation lock, if the combination, or if the number that I'm supposed to put in is 472, if I put in 274, I'm not going to be able to open it, right? Because order matters. That's a different group of numbers than 472. Now in combinations, it's different. In combinations, order doesn't matter. So if I put in 472 or 247 or 742 or 724, anyway, any of those other orders of those 3 numbers, then a combination in theory would open, right? So it's the same kind of thing as, let's go back to our 16 people are running a race. If I say how many different ways are there for someone to come in first, second, and third? How many different ways can we pick a first, second, and third winner? Then that would be a permutation. Because if I come in first and you come in second and Mrs. Abrams comes in third, that's different than if she comes in first and you come in second and I come in third, right? Those are very different groups, right? So that would be a permutation, okay? A combination would be if we are picking the top 3 and we're not ordering them as like first, second, and third. We're just saying the fastest 3 people get to move on to districts. It doesn't matter if I come in before you come in. If I come in first and you come in second and Miss Abrams comes in third, it doesn't matter. It's the same group of people as if you come in first and she comes in second and I come in third. It's the same top 3, right? That's a combination because first, second, and third, I can switch it to third, second, first, and it doesn't matter. Okay? So again, the difference between a combination and a permutation is that in a permutation, order matters, just like this permutation lock. Order matters. I have to put everything in the same order. So I'm going to have more options in a permutation. In a combination, order doesn't matter. So I can pick 3 numbers at random, put them in any order I want, and it's the same group as if I had them in a different order. And so remember, combinations and permutations basically just tell us how many different possibilities they are if we combine certain options.